So the third question that we have is, let x1, x2 and up to x5 is IID binomial 4, 1 by 4. Now we have defined z1 to be max of x1 to x5 and z2 to be min of x1 to x5. So the question is, so this is our first part. It says calculate probability z1 less than equal to. So how will I find it? So we have to find probability that z1 is less than equal to 2. So what is z1? Z1 is probability that max of x1 up to x5 is less than equal to 2. Now what is x1 equal to? So if max is less than, if max of x1, x2 up to x5 is less than equal to 2, so it means that each of these xi's, means x1, x2, x3, x4, x5, each of these random variables are going to be less than equal to 2 because your maximum is less than equal to 2. So we can write probability x1 is less than equal to 2, x2 is less than equal to 2, up to x5 is less than equal to 2. Now it is also given that x1, x2, it is given to us that x1, x2 up to x5 is IID binomial 4, 1 by 4. So since all of these random variables are independent and they follow the same distribution, that is binomial 4, 1 by 4, we can write it as, since all are independent, we can write it separately and we can write probability x1 is less than equal to up to probability x5 is less than equal to. Now since each of these xi's are IID binomial 4, 1 by 4, we can write this as probability x less than equal to the power 5, right? Now what is x? X is binomial 4, 1 by 4. So this can be written as, okay, so let's see. So x is binomial 4, 1 by 4. So x will take the value 0, 1, 2, 3, 4. So probability that x is less than equal to 2. It means in this case we'll have to take probability that x is taking the value 0 plus x is taking the value 1 plus probability that x is taking the value 2. All this to the power 5. So now we'll have to find these three probabilities. So how will I find it? So let's see. So probability x equals 0 is nothing but 4 choose 0, 4c 0, p to the power 0, q to the power 4 minus 0. Probability x equal 1 is 4c1, 1 by 4 to the power 1 and 3 by 4 to the power 3. Probability x equals 2 is 4c2, 1 by 4 to the power 2 and 3 by 4 to the power 2. So if you solve it, you will get 4 choose 0 is 1. So this is 3 by 4 to the power 4. This is going to be 4 times 3 to the power 3 by 4 to the power 4. And this is going to be 4 choose 2. So 4 into, this is 6 into 3 square divided by 4 to the power 4. Now let's find probability z less than equal to 2. So as we can see in the what we have obtained as probability x less than equal to 2 to the power 5 as probability x equals 0. You have to add everything and make it to the power of 5. So let's do this. So you have 3 by 4 to the power 4 plus 4 times 3 cube by 4 to the power 4 plus 6 times 3 square by 4 to the power 4 to the power 5, right? So we can take 1 by 4 outside, 1 by 4 to the power 4 outside. So you will get 1 by 4 to the power 4 outside. Sorry, this is 4 here. So you will get 3 to the power 4 plus 4 times 3 cube plus 6 times 3 square, that is 9 to the power 5. So once you solve it, you will get 243 upon 256 to the power 5. So this is your answer. So following the same information, now we have to find calculate probability of set 2 of 2, right? So what is set 2? So Z2 is minimum of x1, x2 up to x5, and we have to find fz2 of 2. So it means we have to find probability that Z2 is less than equal to 2, right? So what we can write this as? We can write probability that minimum of x1 up to x5 is less than equal to is same as 1 minus probability that minimum of x1 up to x5 is greater than 2. Alright. So why did we write it like this? Because it is given that minimum of x1, x2, x5 is less than equal to 2. So if the minimum is less than equal to 2, that doesn't mean that each of the random variable is going to be less than equal to 2. So if, let's say, if this is your one event A, so this you can write it as probability of A to be 1 minus probability of A complement, right? So A complement is going to be what? A complement is going to be minimum of x1, x2, x5 is greater than 2. So if we write this in this way, so what happens is, like, if we had minimum of x1, x2, x5 is less than equal to 2, in that case we were not able to write that each of these xi's are less than equal to 2. But if we write it in this fashion, then we have 1 minus probability that minimum of x1 to x5 is greater than 2. So if the minimum is greater than 2, if any minimum value is greater than 2, it means each of the random variables is going to be greater than 2, because the minimum is greater than 2. So that is why we have written this in this form, right? So if we proceed further, so you'll write 1 minus probability that each of these xi's, x1 greater than 2, x2 greater than 2, up to x5 greater than 2. So since xi's are IID binomial, xi's are IID binomial 4, 1 by 4. So we can write it as, since these are independent, we can write probability x1 greater than 2, probability x2 greater than 2, up to probability x5 greater than 2. And since each of these xi's are IID binomial, so we can write 1 minus probability that x is greater than 2 to the power 5. Now this you can write it as probability that x is, so now this is x greater than 2, this you can write it as 1 minus probability that x is less than equal to the power 5, right? So in the previous question we have already found probability x less than equal to 2, right? And there it came out to be probability x less than equal to 2. This came out to be 243 by 256. So this we can use it here. So we will write this as 1 minus 243 upon 256 to the power 5. So this will come out to be 1 minus 13 upon 256 to the power 5. So this is your answer for the second part.